I'll turn it over to you now. Take it away.
Awesome, thank you. And yes, let's talk about Scala 3. I think this is traditionally a Scala conference, so most people probably already know about Scala. But just to remind you quickly, it's a language which is both object-oriented and functional. We believe that these paradigms are complementary and not opposed. It targets the JVM primarily, but also JavaScript and native code via Scala native. The language itself is built around a Java-like core. So if you already know Java, you can begin with Scala by writing Java-like code and then gradually incorporate more and more Scala features. Scala is statically typed, prioritizes type safety, and it encourages you to work with immutable values. That's part of being a functional language. We allow imperative code, we allow mutation, but we encourage you to avoid them as standard practice. Scala's been around for quite a while now. We're still working on Scala 2. I'll be building Scala 2.13.7 on Monday, actually. But in parallel, work has been going on Scala 3 for a surprisingly long time, really. The first commit was all the way back in 2012. Scala 3 became final in May, and 3.1 just came out last week. Scala was invented by Martin Odersky, who's a professor at EPFL, the Technical University in Lausanne, Switzerland. And there's a whole consortium of groups and companies that are working on Scala development. On the nonprofit side, at the university, Martin's lab, his research lab is called LAMP. And then he also started a nonprofit affiliated with the university called the Scala Center that does both software development and produces free online courses and sort of oversees the community. On the commercial side, I work at Lightbend. The Scala team at Lightbend maintains Scala 2, and we've also participated in the Scala 3 effort. Just in the last year or two, Virtus Lab, a company in Poland, has stepped up with commercial support for Scala 3, and they're doing a lot of the work on tooling for Scala 3. Let's see, I've already been introduced. I've been at Lightbend since 2015. The questions that I want to answer in this talk are, why upgrade to Scala 3? When is a good time to upgrade? Can you do it now? And when you do it, what's involved? How does this go? Let's start with why upgrade. And I think the core answer to that is twofold. This is a good upgrade because it's an upgrade that I believe we've made as smooth as possible, because Scala 2 and Scala 3 really share a lot. And in the design of Scala 3, there was just enormous emphasis on compatibility and making sure that it was going to be possible for the community and for companies to do this. So much is the same between the two language versions, but there's also a lot of really nice improvements that make the upgrade appealing. So what hasn't changed? What is shared? One of the biggest things is that we put development of the standard library on hold until this transition is complete. Scala 3 uses the Scala 2.13 standard library as is. It is literally the same jar, the same bytes that will be on your class path. So as you're upgrading, you don't have to worry at all about changes in that area. In the language, the Scala 3 compiler accepts nearly all Scala 2 code either as is or with only minor changes. We'll talk a bit about what some of the exceptions are, but like this is really true that most code bases can move without a lot of pain. And because the two versions share so much, it has, even though Scala 3 is pretty new, it has been possible to already have a really large and healthy library ecosystem and a good set of tooling available for Scala 3. So that's why this upgrade is smooth for most people. I'll talk next about why this is an appealing upgrade. What are the benefits? I'll talk about particular features of Scala 3 that I think is appealing, but before I get into that, I just want to really put some emphasis on the big picture of the story behind this upgrade. The really big reason to go to a new major version like this is to put the language on stronger foundations. Stronger foundations both theoretically and practically. The new theoretical foundation is the dot calculus, dot for dependent object types. So that is the formal mathematical basis for the Scala 3 type system. And that's been proven sound, but it was also used as the basis for writing the Scala 3 compiler. On the practical side, the fact that the compiler is new has enabled us to pay down a lot of the tech debt that accumulated in Scala 2. So over the years, since 2003, it's a long time, it's just had become more and more difficult to keep Scala 2 going, to maintain it, to fix bugs, and to add new features. So a new code base for the compiler that is based on everything that we learned from our long experience with Scala 2 really means that it's a new lease on life for Scala that will permit continued improvement and development for a long time yet to come. And you'll see some evidence for that if you look at the Scala 2 bug tracker. You'll see 116 open bugs that are still open in Scala 2 but are fixed in Scala 3. We haven't exhaustively tried to find every such ticket. I bet that there are actually a lot more than those 116. So that's some real evidence that we're seeing overall higher quality with Scala 3 already. In the Scala 3 language design, Martin sought to take things out as well as to add things. So a number of lesser used features are now deprecated, or things which were already deprecated in Scala 2 have been removed. As for new features, a lot of the new features are not completely new. So one of the design themes with Scala 3 was to look at how people were actually using Scala 2, look at common usage patterns or design patterns, you might call them, and turn those common patterns into built-in language features. So a lot of the language features are new at the language level, but will already be familiar to Scala 2 programmers. One example of that is extension methods. In Scala 2, extension methods required using implicits in a very particular way that had to be learned. They're now supported by Scala 3 directly. The old implicit keyword has been replaced by two new keywords, given, which is the keyword you use at the definition site, the place where you're providing implicit values, and the keyword at the use site, where you require an implicit value, is using. And a nice ergonomic improvement is that it's rarely necessary to give your implicits names anymore. That's now much less commonly needed either at the definition site or the use site. Another thing that people used implicits for in Scala 2 was implicit conversions. Those have been redesigned in Scala 3 to be safer. There's less possibility of sort of crosstalk between implicit conversions and other uses of implicits. But although conversions have been redesigned to be safer, we're discouraging them more and more. So if you do use them, please do so judiciously. Something that really is new in the space of implicits is something called context functions. So in Scala 2, methods could take implicit parameters, but function values could not. Scala 3 lifts that limitation, and a function value that takes an implicit parameter is called a context function. Martin expects that this will enable some new programming patterns that we can't necessarily anticipate yet. I don't have time to go into that, but I would like to recommend one talk video which just came out. It's a talk by Martin and two of his students called Representing Monads with Capabilities. It makes good use of context functions. So other benefits in Scala 3. Scala 3 has adopted an indentation-based syntax. That's a type of syntax that you might be familiar with from Python or from Haskell. It allows program structure to be determined not by having to put curly braces around everything, but by using indentation and occasionally an extra colon. So here's the before and after. I want to, assure everyone that there's no plan to drop the old syntax. You're free to continue using the old syntax or to mix them in the same program, even within the same file. Although this is the feature of Scala 3 that was most controversial in the sense of attracting the most discussion. But I think we're finding that as even some people who are skeptical, I would put myself in that camp as initially skeptical, are really liking this. My favorite Scala 3 feature for everyday programming is enumerations. Scala 3 enumerations support simple use cases like you use in Java, but they're more powerful and work for more complex things. Here's an example of a simple use case akin to Java. This is now more concise to express in Scala 3, and it also has better Java interop. You can say extends Java lang enum, and you get something that is easily usable from Java. But Scala 3 enumerations also support more complex things. So once we're free to use Scala 3 features in the standard library, we'll redo this, very commonly used class option in terms of enums. They're powerful enough to represent this. Oh, I've had, if you see the slashes, it's because I'm having to skip slides for reasons of time. Okay, so a major area of improvement in Scala 3 is in metaprogramming. Scala 2 has long supported metaprogramming in the form of macros. But they were always experimental. Even though they're widely used in Scala 2, we still considered them experimental because they were so hard to write. It was hard to write them at all, and it was hard to actually get them right. So Scala 3 discards the Scala 2 macro system entirely and replaces it with a brand new design. And it also adds some language features for metaprogramming that means that macros are needed less often. If you are, so here's some praise from Rex Kerr, a veteran Scala user. He says the metaprogramming capabilities of Scala 3 are amazing compared to Scala 2. And I think this is actually a really common reaction from people who have actually tried this out, that it really is a huge improvement. I mentioned that you don't need to actually write macros as often. The new language features that replace many macros, one is the new keyword inline. Scala 2 already had inlining. There was an inline annotation and an inliner, but the inliner was not widely used, and the inline annotation was just a hint. It was like something you could put in your code, and maybe what you wrote would get inlined and maybe it wouldn't. In Scala 3, when you use the inline keyword, inlining is guaranteed. So you know for sure that the runtime cost of abstracting something behind an inline definition is 0. The type system now includes match types. This replaces, this is useful for doing type level computations. In Scala 2, you either had to use macros for that or do very tricky and fragile things with implicits. Also now directly supported is type class derivation that used to require potentially complex and fragile macros. Okay, so that's a few of my favorite Scala 3 features. I'm in the slides, there's a link to the Scala 3 documentation page that tells you about more. And I would also recommend, if you missed them, watch the videos of the Scala 3 talks that from this conference yesterday, one by Dean Wampler and another by Bill Venners. Both of those were great and don't overlap too much with this talk. Okay, so hopefully I've sort of sold you on the idea of upgrading, and you want to know when you can do this. Can you do it now? I encourage you to be bold on this, because Scala is a statically typed language, and that means that the safety level of doing an upgrade like this is so much more than it is with a language like Python, and they're famously painful 2 to 3 upgrade. Both the type system and the attention to compatibility that's been paid with Scala 3 will help you and protect you. But of course, there are some reasons that you need to proceed cautiously. As with any major technology upgrade, it's always good to start small. Start with a small project, start with a greenfield project, perhaps start with an internal project rather than starting with live production code if you can, in order to build up your expertise and experience with Scala 3 before embarking on a much bigger or more mission critical effort. You'll need to audit your dependencies and make sure that everything on your class path is something that's still going to work in Scala 3. One of the biggest strengths of the Scala 3 compatibility story is that Scala 3 can use Scala 2 libraries. And this is such a big step forward from what we all remember from Scala 2, where every library had to be rebuilt by its maintainers with every major upgrade. With Scala 3, you don't need to wait for the maintainers to upgrade the library. You can just use it. There are 2 big caveats with that. One is macros. I mentioned that Scala 3 has a brand new macro system. So any Scala 2 library that has macros in it, those are not part of this. The maintainers do need to publish those for Scala 3 before you can use them. The other caveat is that you should only use Scala 2 libraries from Scala 3 applications. You should not use Scala 2 libraries from other libraries. And that's because you can run into a diamond dependency problem. You can mix Scala 2 and Scala 3 on the same class path. That works fine, as we see on the left. On the right, we see a bad situation we've got into where the author of library D for Scala 3 depended on a Scala 2 library. If some other Scala 3 library depends on the Scala 3 version of that same library, those will clash. You can't have both of those on the same class path. It won't work. So audit your class path for these problems. I think most library authors are know to avoid this. You'll also need to consider all of the tooling you're using and find out whether that tooling is Scala 3 ready. IDE support for Scala 3 is already pretty good. IntelliJ works well. Metals with VS Code works well. Also Metals with some other editors. But you'll want to kind of take inventory of all the tooling that you need. I think you will be pleasantly surprised at how much other things already work. Okay, so suppose you are ready to upgrade. How does this actually work? And I have a series of little bits of advice on this. First of all, don't try to, if you're on an old Scala 2 version, don't try to go directly from an old one to 3. Get to Scala 2.13 first, then make the jump to 3. That will really make your life easier. If you are cross-building, which means that you're compiling your code on more than one Scala version, drop 2.12 from your cross-build if you can. It is definitely possible to cross-build against all three, to cross-build against 2.12 and 2.13 and 3. And actually, a lot of the library ecosystem is actually doing this. But if you are free to drop 2.12 from your cross-build, you'll really make your life easier, because then you won't have to worry about 2.12 and 2.13 having not only different compilers, but different standard libraries. Before you flip the switch and try Scala 3 on your existing code base, it's a good time to look at all of the warnings that are coming out of your build and actually pay attention to them. So any real life code base that doesn't have fatal warnings enabled, inevitably the warnings pile up. This is the time to actually look at those. A lot of those warnings have a potential to be warning you about things that you were like getting away with in Scala 2 that you're no longer going to be able to get away with in Scala 3. Once you've cleaned that stuff up, then enable this new Scala 2 compiler flag called xsource3 that asks the compiler to produce even more warnings about things that may need attention before you upgrade. I can only give you so much advice about migration. That the complete source on this is the Scala migration guide, which the Scala Center did a really fantastic and really thorough job on. Do read that, and consider using another Scala Center project called the Scala 3 migration tool. So this is something that will actually attempt to analyze your build and analyze your code and let you know about things that you should change for 3. Once you have flipped the switch and you're running your code through the Scala 3 compiler, there's 2 compiler flags you should know about. One is this -source 3.0 migration. that will ask the compiler to emit additional advice. And dash rewrite, if you enable it, will actually modify your code to be Scala 3 style rather than Scala 2 style. I believe that the Scala 3 migration tool also does that, but if for some reason you aren't using that tool, you can still use dash rewrite separately, just as a compiler flag. You'll need to decide what your point of view is on indentation-based syntax. I think some teams will stick with the old syntax. Some teams will convert their entire code bases. I think the most typical approach is to move gradually. This is what the Scala 3 team are doing themselves with their own code bases, is they're just, they convert to the new syntax when they are actively working on an area of the code. And this works because you're free to mix the two syntaxes. You can mix them in the same file, even within the same class, you can mix them. And so I think gradually adopting the new syntax, it works fine, and it's what I often see people actually doing. I'd like to close now by recommending what I think are the most valuable learning materials for Scala 3. At least the ones that I know about, and that I'm confident recommending. The Scala Center, in collaboration with 47 Degrees, has a great series of videos called Let's Talk About Scala 3. There's 12 of them. Each of them is on a different topic. So they're not like a sequence. So you can pick and choose the topics that you're interested in. The Scala Center's free online courses have been updated for Scala 3. Some of the courses are classics that they've been running for years, that they updated, most notably functional programming principles in Scala. They also made a new course for Scala 3 only called Effective Programming in Scala. It's another getting started with Scala course, but it has, I would contrast it with functional programming principles by saying that functional programming principles feels more like a university class, whereas effective programming is more like an on-the-job class. They tried to be extremely practical, like what are the essentials that I need to know in order to be productive in Scala 3 at work. A number of Scala 3 books are now also available. Alvin Alexander wrote a book that's just called the Scala 3 book. That is available for free on the Scala documentation site. Dean Wampler updated his classic Scala book for Scala 3, and I wrote the foreword to that, so that's a favorite of mine. I also strongly recommend Bill Venner's book, which he has updated for Scala 3. And then in progress is a Scala 3 version of Functional Programming in Scala, which is really a classic book for people interested in pure functional programming. Mike Pilquist from Type Level is in the process of updating that for Scala 3, and a preview of that is already available. And it looks like I finished with 30 seconds to spare. I will now close Zoom and I will head over to the spatial chat. Happy to answer your questions.